Hello everyone. We'll be learning the concepts of generative AI as part of curriculum under the head professional elective for 4th year first semester. So as part of your curriculum you have already learned what exactly is machine learning, deep learning, and you have learned NLP also. So now we shall see the next domain of artificial intelligence, wherein we will be talking about generative AI concepts, its architecture, its variants, how many models are there, all these concepts. So coming to introduction of generative AI, what exactly is generative AI, how different it is from the discriminative models, let us have a brief look of that. Generative AI refers to the field of artificial intelligence or the area of artificial intelligence which tries to generate new content like audio, video, music, whatever we say. So it is trying to generate new content wherein suppose human being also has generated some content. You cannot distinguish between the content generated by a human and generative AI. They are almost looking similar that distinguishing them separately becomes very tough for us. So I will just talk about a small example. Say for example, we have seen somebody morphing somebody's picture. If you zoom it to a maximum level, you can still find out that it is a morphed image. Somebody has done some kind of pasting onto the original image. So you can easily make out it's a morphed image. So you are able to distinguish. But whereas when you are generating a content through generative AI models, it becomes very tough for us to distinguish between whether it is the original content or generated content. So that is where generative AI is trying to leap its features, wherein we are trying to generate new content from the existing content and we are unable to distinguish from the human generated content. Unlike the existing discriminative models, wherein you are trying to predict the labels. When you are working with machine learning, you are trying to predict the labels for a particular object. Similarly, you are working with the deep learning, natural language processing and all. So all those discriminative models wherein you are trying to predict the labels, generative AI, what it will try to do is, it will try to learn the underlying distribution of the data that you have given, and it will try to generate new samples from the existing data. So it is trying to learn the underlying behavior of the data set and it is trying to generate new content. Just because it is generating new content and learning from the existing data set, we say this is the domain of artificial intelligence which is generative, right? Then we have learned various things of artificial intelligence. In what way generative AI is different from traditional artificial intelligence? When talking about traditional artificial intelligence, it takes care of the common tasks like spam detection, fraud detection, or spam mail filtering, all such things. And sometimes it will be easy for the researchers to find out what are the underlying algorithms when I am working with the traditional artificial intelligence models. Whereas if you are working with generative AI, we are trying to concentrate on content creation, wherein it is generating new documents, it is generating new music, and it is generating images, so many things. There is no field where generative AI has not put its leg into. So it can be what happens is, with the traditional artificial intelligence, we are able to predict the algorithm which was used to do a particular task. Whereas in generative AI, it becomes tough for the people to identify what is the algorithm it is using in order to do a particular task and how it is arriving at a specific output. That is a very tough task for the people who are working with generative AI models. One simple example I can talk about is we are trying to see ChatGPT is generating too much new content, and these days we are listening to old songs as if they are sung by the new playback singers. Suppose I have a song which was recorded by an old playback singer. Now you are trying to generate the same song as if a new playback singer has sung it. We are unable to make out whether it is just generated or that particular person has really sung that song. We are unable to distinguish, and you cannot even exactly tell which algorithm we are using in order to generate so closely generated content, right? So when you are working with the generative AI, identifying the underlying algorithm will be very tough for us, and what algorithm it is using in order to generate the new content is also not easily predictable. Then, how did this generative AI evolved? We learnt machine learning, you learnt deep learning also, you learnt natural language processing also. So, how far generative AI has evolved so far and where it has exactly started with. So, the evolution of generative AI can be put like this: in the early developments in AI and machine learning during 1950s to 80s, what we were doing is we try to take the data set and predict a particular output, or you try to take a data set, give the test data and try to do the classification. So, machine learning was working very well as long as the data set is comparatively a smaller one and it is not having much of new content generation. It is taking the existing data set and trying to predict or classify whatever question you are asking. So, in 1980s to 90s, what we were trying to do is we wanted to go little bit further. We wanted to simulate the behavior of neurons which exist in human brain, and we wanted to have the similar kind of functionality. That is where we might have learnt various types of neural networks. Then, with the advent of deep learning somewhere in 2000 to 2010, what we tried to do is we tried to increase the computational power, and we were also trying to increase the size of the data set, and the way it is answering the questions is also slightly different from the machine learning models. Then in 2006, the deep belief networks were introduced, which tried to think of the way deep learning is previously doing. Now it has totally changed the dimension. Then between these things, we also have the translations wherein we are working with the natural language processing and all. So, all these things, what they are trying to do is they are trying to work under the domain of natural language understanding. With the advent of generative AI, you are not only trying to understand the existing data set, you are trying to generate new content. This is where the huge difference is done by generative AI. So, let us talk about the emergence of generative AI models, wherein you have autoencoders, then variational autoencoders, VAEs and so on, which are trying to work on compressions and reconstruction of the data, and they are also trying to work on the probabilistic models in order to generate new data. So, these are all various things which are working under generative AI. We will be seeing each and every component as part of our syllabus. Then in 2014, Ian Goodfellow, he has introduced the GAN, generative adversarial networks. What it has done is it has revolutionized the generative modeling. What it has done is you are trying to work with the two types of neural networks. One will work as a discriminator, the one will be working as a evaluator. So, you are trying to build a kind of competition between two types of neural networks, and you are trying to identify the originality of the content. Then We have seen transformers as part of NLP and large language models. These days we are listening to this word LLM very frequently. So in 2017, the transformer architecture was introduced. So compared to natural language processing, why we are going for the concept of transformers, wherein you want to work exclusively on sequence to sequence generations. So most of the time I want to work on sequence of sentences and parallel computation of sequence to sequence translation. We are going for the concept of transformers. Now 2008 till date, what happened is development of large language models, which has totally became oxygen for most of us, ChatGPT. Right. So we are trying to start with the GPT 2, 3, right now we are seeing up to ChatGPT 4. So we will be talking about how this generative AI has leaping into every aspect of human life and how it is generating new content, what algorithms it is using, what are the architectural aspects of that, all these things. So if you just see this diagram, we started with artificial intelligence, that is the traditional AI. Then we were looking at machine learning, which was focusing on data and algorithms. Then deep learning, which was trying to use statistics and predictive modelings. And up to this, they were helping us to take some decisions. Whereas generative AI, it is trying to create new content. This is the difference, where it is trying to make. With this, artificial intelligence has stepped into everybody's life, whereas all these things were stopping at researchers' doorstep. Then types of generative AI models, just quickly look at various types of models. Autoregressive models, these models will be predicting what will be the next point based on existing points or previous points, right. So these are various examples of autoregressive models, and these are the applications where autoregressive models will be used under text generation, audio generation and image generation. The next category, autoencoders. We will be talking about autoencoders, wherein you talk about variational autoencoders, which are trying to go for image synthesis, text generation and anomaly detections. In case of any anomalies in the generated content, how do I detect that? So all these places or all these applications are trying to use variational autoencoders. Then GANs, what are they trying to do? They are trying to work with two types of neural networks. One is the generator, the other one is the discriminator, and both of them are trained just like a game theory framework, and the generator creates the synthetic data. The discriminator tries to evaluate the generated data. At one point of time, the discriminator should be able to feel as if the generated data is original one, not any synthetic data. So you are trying to reduce the difference between the synthetic data with the natural content. So these are the applications where GANs are used: image generation, video generation, deep fake. Seriously, we are trying to witness too much of deep fake images and videos these days. So that is happening through the GAN. Then normalizing flows, when you want to work with normalizing flows is a kind of simple probability distribution, and you want to convert that simple probability distribution into a complex distribution, and you can try to convert it into a series of invertible points or invertible transformations. They are going to train the models very straightforwardly, compare it to GAN and variable autoencoders and all, and which is trying to help us under density estimation, video generation and image generation. You are too much into statistical information and probabilistic information, better we go for normalizing flows. Similarly, energy based models, wherein you try to define a scalar energy and start generating the data from the low energy levels, and you try to go up to higher energy levels. So these are the example areas where we are going to work with them. Image generation, and the data is unsupervised learning model, all these things. Similarly, reinforcement learning, again this is one more area which is prevailing into our lives. So these are the models which will try to generate the data by treating the generation process as a sequential decision making problem. At every step of data generation, we try to make a decision. So you are going to associate with every data point that is generated the value of it and the penalty of it, the reward point as well as the penalty point of that, you are going to associate with that. So these are the application areas where it is going to be used. Similarly, deep belief networks is the area which is trying to have its features under feature learning, data generation and dimensionality reductions. All these models, there are some more models also. We don't say we are going to exactly use these models. Each feature has its own strength and weakness. So we have to choose the model which exclusively suits the application which we are going to work with. And what are various applications of generative AI? Specifically image generation, then text generation. Image generation, I need not talk much on this because we are actually experiencing this. The moment you go into social networking websites, you cannot exactly tell whether a picture is generative AI or AI generated image, or actually somebody has taken a pic of a particular scenery. So image generation, text generation, chat GPT, every possible question in every possible manner, it is trying to give you the new content. Then music generation, as I have given the example, you can generate various music contents based on the existing data. Healthcare, maybe without healthcare domain, we cannot finish AI application. AI is so deep into healthcare domain, without which you cannot even talk about the applications of AI. Similarly, art and creativity, and these are the other applications wherein you are talking about data augmentation and simulation and modeling. These are the various applications. I have just listed out some of the domains where generative AI is finding its applications, but there are some more. We can keep on enhancing the list. Thank you.